Ladies and gentlemen, partners, friends, and also 3D nerds, heartily welcome to our next live webinar here at the DETAX Academy. Today, we will show you the process with SplintMaster material. Together here today with Matthias Zimmerer. I'm so happy he's here with me. So Matthias Zimmerer, can you please introduce yourself a bit?
Yes, of course. Welcome. Thank you, Marcus, for the invitation to the DETAX Academy. And I'm proud to can show you some bite splint design in Exocad for printing with the new SplintMaster material from DETAX. And I'm so happy to be here, and I'm so proud that you have invited me.
Thanks. So I think we will have a lot of fun today. We will show you the print process also, and we will start at first with the modeling step in Exocad. So Matthias is the godfather of Exocad modeling, and after that I will show you the composer software, how to prepare the print job. Later we will print, wash, cure, and also Matthias will show us the finishing of the splints. I think let us start at first with the modeling step. Yes, Matthias,
yes,
it's for you.
This is my part, and I'm happy that we can start now. So in Exocad, I think everybody knows how to make the case for the splints, and we have a lower jaw splint with removement data because it's called the Highend Splint in Exocad, and so we use the best you can get, and I will show you everything what is possible here. Yes. So this case is the lower jaw splint, and now we start the design of this. We're loading the jaws. It takes a few seconds. And the removement data. It's the connection tray for the upper jaw. So we have to align this upper jaw connection tray that you can get the Zebras movement data here in the software. It's just a
So Matthias, one question from my side. This is a matching step, isn't it?
Or... Yes, this is a matching step of the for the removement data.
Mm-hmm.
Just have to correct this. Normally it's working a little bit better. It's just go back if it doesn't work and try it again.
So this is live, this is the good situation, you know, but you can go to the step before and start it once more again because the algorithm needs to calculate it new, right?
Yes, this is the problem. Sometimes Perfect. It's a little bit tricky, but now it's good and it's fitting and we can work on. We got all the bite situation from the doctor. He's made his registration and has made the scans new, and so we can just design, we can concentrate on designing the splint and getting the best for the patient, yes? We have some 3D cutting options here and designing now the splint bottom. Yes, this is one of the things we have to watch out in the design options. We have here the block out of the undercuts. I always would say it's always a question if you want it a little bit tighter or a little bit wider. And I would say make it just a little bit wider at a 0.05 millimeters is, in my opinion, the best option for the design because the splint bottom can sometimes go crazy on 0.03. Yes? If you have a 3D printed splint, I always will say you have to make the undercuts option a little bit higher. Yes, I always would say making undercuts allowed to be 0.2 0.2 or 0.3. This is the best option. Always belong, if the material is a little bit softer, you have to get the higher undercuts. Yes? The smoothing of the undercuts is the standard value, 17%. If you get this lower, you will get a better splint bottom, who's following better the lower jaw in this case. Yes, and I always let the standard value here at 17%. Yes, milling diameter always, if we print, we doesn't need normally 0.1. Is the best for 3D printing, in my opinion. So we get the insertion direction, choose this, and apply. It's calculating the splint bottom. And after it is calculated, we can freeform this bottom. Yes, we have to freeform always, in my opinion. Yes, in the front, normally I don't need these undercuts because normally they all make problems at the end, and I don't need normally. Also in the intersections, I would get these undercuts away because sometimes people are asking why. If I tell the doctor the splint is too tough, yes, I can tell my doctor just grind a little bit there. Yes, if I tell the doctor he has to grind everywhere, it isn't possible to get the fitting of the splint. If the splint doesn't fit, normally it's not a problem of a digital production way. It's more a problem of will I get the splint from an impression, or is it a digital impression? And normally in the digital impressions, I get very less problems. So I always will get the undercuts a little far away here. Also an option is the splint will go in very soft and will get a light click at the end. And this is what people normally would to have. Yes. This is the reason why I take away the undercuts here on the bottom. So, I'm clicking too fast for my computer a little bit. But I will get this away, and so I have islands where I can get the best fit option for my splint. Yes, the softer the material will be, the more undercuts I give here at the end. I can control it. If I don't have undercuts, then you are right, you have the problems, you have to make it a little bit tighter, and then you will go with the blockout offset a little bit to 0.03. Okay, this is an option, but if you have a look at the cut view, you always will see what happens with your bottom, with your splint bottom. Yes, and this is one of the things why I say at 0.05 the splint bottoms are calculated on the best way. Just give it a little bit more tight on the undercuts and the problems will gone. Also, if some problems with the impressions are there, you can compensate this. Yes? The design for the splint bottom is ready, and we just go to the next option. Design of the splint at the end. Yes? Just calculating again. Yes. So, the virtual articulator. We have two options, and if we use the real movement data of the patient for the high-end splint, we don't need normally a virtual articulator. In this case, we are used normally. Yes, we using real movement data. Real movement data is the movement of the patient in real. This is why it's called so. And I can load in Exocad something here. Out of various systems, here we have used the Zebras system, and we have here the Zebras real movement data. So we load, we say this is the reference position, and we will use normally for our movement the lateral left and lateral right position. Also, you can use the protrusion, but Normally, lateral is the one we are using, yes. We have here include the selected parts and generate the virtual imprint, and don't want to include any restorations, and have got our virtual imprints. Here, if we use, this is the virtual imprints. It's an static 3D data. We also, if you want to go with crowns and bridge back to the analog way, we can make therefore out of the model creator a 3D printed model, and you have all the dynamic occlusion data in a static model. So it's finished, and we go to the next step. This is the modulation of the splint. I always would recommend to design the splint on the splint bottom and not on the shown model. The splint bottom you can choose here on byte splint parts, and the splint bottom you can blend it in. So you will see. I have just a recalculation here. Normally I would freeform the splint bottom again here, but now we are live. You have seen what I made with the undercuts, and normally I get this away, yes? So we make surface properties here, occlusal thickness on 2.5. This is normally good. I can always belongs on the byte situation I will get. In this case, I will say 2.5 is a little bit too less, yes? So I will make normally the maximum and let cut it on, yes? The peripheral is on the buccal and the lingual side here, and I would always recommend 1 millimeter is good. If 3D printed, I would take it a little bit higher. 1.2, 1.3, 4 is always a little bit better if it's a little bit thicker. Yes. Smoothing, the higher the values here of the smoothing are, the flatter the splint will be at the end. The surface smoothness I will mean, and always I will get here to the design of the splint. Just set my points. In the front, I will take it a little bit shorter. I can click it away and make the design. I always can now control where are in the undercuts. And close it with double click. I will tell the software the posterior area always belongs on the splint design I want to get, yes, but normally it's the most of the doctors will have this, yes. The impression depth of the posterior area normally will be 0.4. You can make it a little bit less if you want. This is a very individual decision, yes, but there you will get a cutted area here. So, next step is the freeforming of the splint. You can have, look here, we can adjust our design. What I would always prefer is to make it smooth, yes. The smoother the surface of the design, the smoother the print at the end will be, yes. I don't have adjusted the occlusion till now. What I will do, it's always a smoothing option here. Make it flat. If you want to make it here a little bit thicker for the stability, you can make this always, and also get the best option here for the antagonist. So adapt, and we can make just one static occlusion adaptation. It's cut it away, and always have a look if the antagonist is best supported here, and then we have to get to the dynamic occlusion. This is the occlusion, it will cut on the movement of the patient. If you have a look at here, this is high-end splint, yes? You don't have a virtual articulator, it's just making the left or right lateral movement. It's the patient movement, yes? It's nothing we have made out of any ideas. It is what the patient gave us. You have here the best.
So, Matthias, for my information,
Yes.
this is a perfect situation. So we have the real situation of the patient,
Yes.
and this is not calculated or something
No.
like this.
No.
Because with this option, we can prepare perfect splints, perfect fitting splints for the patient,
Yes.
right?
Yes.
Individual situation.
Yes.
That's perfect. Okay.
Yes. This is the movement, and the patient give us this movement.
Yeah.
Yes, it's nothing we have out of an normally articulator. We use it every day, normally in Exocad. This is the real movement the patient has. And if you see here, we also have the option, if you use the real movement, we can let move the lower jaw. Normally in the software, always the upper jaw is moved, also in the articulators, in the analog. Yes?
Yes.
But here we have the option to move the lower jaw, and this is something totally new, yes? And this is the best you can get for the patient.
This is one of the big benefits in the digital workflow,
Yes.
right?
Yes.
Perfect.
Normally, you don't need any model for this, yes? No physical model. You can print the splints out of the intraoral scans, and this is no problem. It's quite quick and easy, I would say, and always you will see where are the contacts have to be. You can move it away, or if you say I would more movement for the canine, you can take here a little more, like you want. There are so various options you can make here a set on it, and if you say on this point I will cut it away for with a little bit impression, I can say, okay, I will here go through just for this and just on this point here. And I can say I have here a little bit out of the rest of the splint. Yes, if I want here more movement. So I will smooth it, I will have a look if it's anything okay. This is the best thing I can do. And there we got the finished splint. With real movement data, the best of both worlds, yes. The best for the patient. This is the finished splint then. So.
Perfect. Thank you very much. I learned a lot, especially the situation with the real patient situation is pretty good for me, I think. But in the background, I think the dental technician needs to talk with the doctors close together
Yes.
about this point.
Yes.
Thank you very much. The STL file is saved, right? So we can start now with the composer process, means we will prepare the print job and create the supports and so on. I need to go to the computer and will show you the composer now. Okay, so I can open the composer software, as you can see here right now, and we will prepare a new print job. Here it is, we will prepare it for the Asiga Max. We select the FreePrint SPLINTMASTER taff material. So we have the taff material and also the soft material. The thickness of the layers will be 100 microns. This is our platform of the Asiga printer now. We will add the parts we will print. So the part was just created from Matthias for us for this workshop. In this case, it is flat, but it is not on the right side, so it means we need to reset the position. It is possible to print the splints flat, of course. It is also possible to print to print it vertical. We tested all the situations, all the different degrees. So you can, like this, you can print it flat if it's needed fast. Sometimes you have some express orders and you need in the next half an hour the finished splint. From my point of view, a better situation is to print it nearly 50, 55 degrees, but it's also possible to print it in 90 degrees. 90 degrees is a bit, oh sorry, this is the wrong direction, in this direction. 45 degrees, 50 degrees, or also 90 degrees. 90 degrees is a bit critical because you don't have so much connecting points of the supports. I like to work 45 or 50 degrees. So you get more splints on the platform, but as I said, if you need it fast, you can print it also flat. Okay, we will double it, copy it now only to make 2 splints on this platform. And what is needed now, we will create some supports. In the regular style, in our ini file, we have some standard supports. These supports are a little bit thicker and less supports. I love to work with more supports, but much more thinner. So that means we use these settings here. That is not a problem. You can send us an email or use on DETAX.de our chat function, and the back office and the support will send you the settings for these supports. This is easy to implement it in the system. For all our objects, we will create the supports. Create the supports means the position. Now you can see it is not correct on the platform. The position later will be perfect. It's 2 millimeters higher than the platform is. And we can say apply. And in the background, you can see here the supports will be created automatically. Okay, so we need to check it because we have some areas we don't like the supports, but here in this case, or it is easier, you can also use the option X-ray mode. The X-ray mode means it is you can see also inside of the objects, and it is a bit easier to see the connection areas as you see here in this area, the connection areas of the supports. And if there's some support here in the visual area, you can delete it. This is not a problem at all. The X-ray mode, the X-ray mode let us see inside of the objects, and we can delete or we can set some more supports if it's needed. But in this case, from my point of view, it looks good. It looks fine. So let us switch back to the normal mode like this. And we can create the print job. That's all what is needed. We say press the play button. I say play button, but it's a build button. Normally you can write here your batch number of the material. At the moment we don't have the batch number, so I select X only. On the bottom here you can see this is 1 hour 52 minutes. This is a special situation here because we use the function that the supports will be cured with 200% light energy and the objects only with 100%. It takes a little bit longer than the regular print job. The regular print job for this splints is about 1 hour, 1 hour 5 minutes. Why do we use this option? Because if the support during the print job will be cured more than the splint by themselves, that means, you will see it later, if you crash the supports away from the contact area, the supports will crash away and nothing from the surface will go out of the material. That's a big benefit, and it makes it much more easier to less the supports. I will show you later in the process. Here we have the fast mode was not set, so now you can see it is 1 hour 17 minutes. It is much more faster. You can use it, of course, it's not a problem at all. Let's go to the next step. The settings are all the settings you can get from the ini file from us. This is also not a problem. We need a name for the print job now, and now we can say send the build to the printer. The printer is connected. That means now will we produce the slices, the pictures, let me say, of the print job, because we need for each layer we need a picture, and this calculation step needs a little bit time, but it is okay. So now it's ready. The last step before you start the print job. The print job is now sent to the printer. You can select it on the printer, but now please use the function view slices. You can see here, this is the picture what the printer will do and will use later. You can press the play button and you can see the supports now is white, and our object here is good connected to the supports, and the object is a little bit gray. That means the support is cured more than the object, than the splint later. This is what we like to use. Looks good. So the first connection areas are connected to the supports. The print job is sent to the printer. Before the webinar we start the printer with the same, nearly the same splints. We print it flat, only to show you now how easy it is to lose it. From this point, I will go to the printer now and talk with you a little bit about the material before. This is our brand new master splint material. Here you can see it is in a new design of the bottle, absolutely brand new design, and it's a little secret, so don't talk about this. This is for the next year only, because the material will be finished for you to buy it in the beginning of the next year. That is the goal. We hope it works. At the moment, we are in the middle of the registration step, so it's for FDA, for the USA, and also for MDR in Europe. But I don't know how long the notified bodies needs to control, to check it after we got the loudness or the certificate. But now let us start with the Splintmaster taff version. As I said, we have also the soft version. It is completely the same process until the finishing step. Finish, it's a bit different, but the printing process is 100% the same. As I said, we printed before we start the webinar. We printed a print job that I can show you now how it works to lose the objects from the platform. And please also, if you use our material or all the other materials, every time if you work with the liquid material, you use the gloves. We can open it, lose the platform, take it out carefully, and take it by side. If you will print the next print job with the same material, it is not needed to take all the rest material of the platform away. If you will change the material later, assemble for model, for denture, for some others, please use a normal paper card and take the rest of the material away from the platform. It solves material for you. If you don't do it, it is good for us. It's up to you. I love to work with a Japanese spatula like this one. It is super flexible, and the big benefit is it's totally thin. It's much more thinner than the regular spatula. On this process steps, the last time I showed you to use a small hammer like this for denture, for crowns, or some other really hard materials. It is much more easier to lose it with a little hammer, to knock soft on it, and it will fall down. In this case, for the splint material, it is not needed, because as you can see here, I hope you can see it, it is so easy to lose. You need to go under one corner here, and the rest will fall down by themselves. I use about 45 degrees from the spatula to the platform. And now, if you use the same material, we can take the platform directly back to the printer. Close it. It is enough material here inside. For the last print job, it's okay. As you saw, we sent the print job to the printer. The name is webinar. We select it and start the print job. Now the printer, in the same time, we will wash and clear and cure the other parts. The printer can prepare the next one. So one step here, we talked about the supports. This is really thin supports, and we have a lot of supports. And as you can see, that is not so easy. Here you can lose it totally easy with your hand. It is an easy step. I need to be careful that nothing not drops down here. And the surface, you can over the surface with your finger. It is nearly perfect. Not 100%, but it's nearly perfect. So that means I cut the supports of the splints away before I used the first washing step, because here is also a lot of not cured material. Show you. Here's also a lot of not cured material inside, and if we take the supports inside of the cleaning bath with the isopropanol alcohol, you cannot use it so long, let me say. The washing step is the same like all the other materials. We have two different boxes. We marked it with A and B. A is the material for the first washing step. It is not so 100% clean. It is only to make the most of the material, of the non-cured material away. So we can take the splints here inside, close it, because here is, as you can see, it is isopropanol alcohol inside. And this is marked with an A, so I know it is the first washing step. Take it into the ultrasonic bath, and please, the ultrasonic bath is filled with water. Inside of the water bath, we take our plastic box filled with isopropanol alcohol and our objects we want to clean. Now we can start it. The first washing step, it's 3 minutes. I will stop it here because we don't want to wait for the 3 minutes. The next curing step is, the next washing step is in the other box with the mark B, and it is clean isopropanol alcohol inside. So that means if this the second step, the isopropanol alcohol, is not clean enough, you can take it into the bath number 1 or A and use for the second step really clean isopropanol alcohol. Here are some splints inside. Take it in the ultrasonic bath, same for 3 minutes, take it out, and I will show you. You can use, that's what I learned, if you remember, that's what I learned on the last webinar. This tool is a tweezer. Yeah. So you can take it out of the tweezer. It's not needed to take your hands here inside of the isopropanol alcohol. Take it out, then you can use take it in your hand, and you can blow it and dry it with compressed air, regular compressed air. And if it's dry, we can go to the next step. The next step is the curing step. It's one of the most important steps because during the curing step, the material will shrink a little bit. That means the splints now is a little bit too big. And after curing, it is some perfect fitting and got the perfect result. The splints, in this case, we use an auto flash machine. Take it in when it's dry, close the hood. We need nitrogen inside of the chamber because nitrogen takes the oxygen away. And if there's too much oxygen inside of the chamber, you will get a sticky surface, and then it's not completely cured. So we will start 2000 flashes for the first step. And you can see the gas, the nitrogen is on, all works fine. I will stop this process now because it takes also a bit time. After the 2000 curing steps, we can turn around the objects and cure it for one more 2000 flashes. After the second time 2000 flashes, the material is finally cured, and we have here some splints, and you can see it's a little bit mud, but I think in 2 months we will do another webinar workshop how to print, wash and cure the splints with a perfect surface, and it is also not mud, it is clear, 100% clear, but it will come later. After curing, the material is ready for the finishing process. But let me lost some words about the material by themselves. It is with a cured material, it is absolutely possible. You can use a hammer if you like and knock on it. Nothing will happen. And also, I will show you here in detail, you can deform it a lot and it will go back to the original position. And if it's possible to break it, but it's not so easy. Oh, I'm sorry, I can't. But if it breaks, it will break without any splitter or something like this. It is a clear cutting line that nothing happens with the patient later. All the materials you can break, of course, but for this material, it's really hard to break. So I will show you, but I'm sorry for that. I can't break it. I hope you can see it here. It is much deformed. Okay, for the finishing process, Matthias, please be so kind and show us some finishing process about polishing or something like this. And after that, I will come back to you to give you some more information. And also, we have a lot of questions in the live chat. I will come back to you later. Matthias, it's your part.
Thank you, Markus.
Thanks.
I will show you at the finishing station here. Can you give me the splint for the polishing?
The splint.
Yes. I need your help. Fresh out of the auto flash machine. Yes, it's totally cured. You will see in here. And we will proof the splints for rests of the supports, and they are really not so much. Yes. For the first time, I will always use a little burr, yes, just to get the surface a little bit clean and out of the contacts, but they are really, I have to say, not so much, yes, just a little bit. So, this is the first step. Then I always use a little brittle here, also for the first time of the occlusion problems. There were the supports was, yes, but the surface is really good. Just to get a nice finish here. You also can use some polishing machines also. Yes, this is not a problem. But in this case, we will make it with the handpiece. Also with some polishing. Just to get a nice surface, and don't use too much force on the surface. Yes, always let it run lightly on top. And on the inside a little bit. You will see it getting much more clear. So,
So Matthias, later we will prepare a short how-to guide or
Yes.
a list with the tools and the material you use
yes, I would also
for
say,
the polishing. And this is the same situation. Please let us know. Visit our DETAX.de website, and you can send us a mail, or you can also use the live chat function, and we will send you the how-to guide later. This is that you know what is needed for the polishing step.
this is not so much, and the most of you will have it in the lab. Yes, but it's always good to have an guide for this. And so not too much force on the surface, and always use a little bit of the polishing materials. I use here an used one, always for the first two. This is a little bit rough. This is much more fine. And here we have a compound, and we see it nearly good all the way inside. And then we use the next with a new one, and also get here. It's always normally been better to use a dust collector on your place, your working bench. Yes. of
That's
course.
the problem with the webinars, you know, you
Yes.
can't hear what you say if you use a sucking machine.
Yes, this is always a problem.
Yeah.
But normally I would say, don't inhalate this. This is not recommended. And then it's really good. You will see it very smooth. Some of my colleagues would make some special surfaces on it with lac or with a second layer of resin. I have also talked with Marcus about this, and I think he can explain you why you doesn't have to do this.
Yes, of course, of course. So the first thing is, if you use later material, fresh material, liquid material, the fitting situation will be not so perfect situation, because the object we printed, washed and cured is a perfect situation, as we saw before in the modeling step for the patients. If you use later some coating, lacquer, raw material or something like this, you will you have a bit more on the surface, and that means the fitting is not perfect. Also, if you use coating or some other things, the mechanical properties will be not better, it will be more worse. So that, from my point of view, it makes no sense. The polishing situation is good. And what I said before, the next webinar, we will show you how to print this one, the splints, with a smooth surface, so that it is polished directly after printing. This is what we like to do.
Sounds very interesting. I will have a look at it. So we nearly finished. Normally we can take it at the end again in some ultrasonic, yes, for a few minutes to clean it just in water, not in the isopropanol, yes.
Yep. Yes.
And then the splint is ready to go to the doctor, and then in the patient's mouth. And I would say it's not a big thing. Yes, it's so quick and easy, and
Absolutely.
you get a
Yeah.
perfect splint for your patient and for your doctor.
So Matthias, I think the rest
Yes.
is clear for
Yes.
the dental technicians.
Yes.
You can use the time if you like to wash it, and we will show it later in detail.
Yes.
And I will use the time because the time is running, of course. We have a live chat in the background, and let me see to the desk. We have some questions. There's a question, when is the material available for us? Okay, we are in the middle of the registration step, so that means our MDR and also the FDA registration will be started. I keep my fingers crossed, in the beginning of the next year it will be ready. And there's another question from Irina about the price of the material. Please talk to your dealer. When the material is available, you can get the material from your dealer. You can also talk about the price with him or contact your direct partner here at DETAX. The next question is about the wall thickness. The wall thickness will be much more thinner than at the moment. The final data we will send you, it's also written in the instructions for use, of course. Oh, Matthias, there's one question about the modeling step. I don't understand it correctly, but you have to make some settings in ExoCut.
Yes.
For the placement between the teeth and the splints.
Yes.
For the other materials, we have some data inside of ExoCut.
Yes.
We will prepare it also, and later you can download it, or it's in ExoCut, and you can select the DETAX material, and then it will be
Yes,
ready.
in the ExoPrint you have presets also for the printers. Yes,
Yeah.
you can just choose your printer and take the material out of the list for out of the work params normally. Yes, and you can, if you make the setup for the splint, yes, you can choose DETAX SPLINTMASTER, and all the settings are there.
Okay, perfect. It's also easy, totally easy to work with, and the settings we will prepare, and when the material is on the market, you can
then
select
it
the
also
settings.
will be downloadable at ExoCut also.
Yes.
For all the guys, they don't have the work params at the moment. You can add it later also.
Perfect. Okay, sounds good. So another questions about the splint material. Oh yes, we have two different versions. That's what I said also before. We have the tough version and also a soft version for different applications. It is a question what is needed for your application. So we have a lot of more questions here. I think it's more than 200 questions in the live chat. Our back office will answer all your questions, and also later the questions. We have a lot of questions about the support styles. That's what I saw. You will get the answer, but now it's not the time to answer all your questions.
Also, if some questions about ExoCut at the end, also just keep it to DETAX, yes, and they will get it to me, and I will come back to you.
Perfect. Yes. Thank you. That's good. Great. So we talked about the material. We showed you some process steps. We showed you the benefits of the material. You know some other materials in the market. It's a bit more blue shiny or some other materials. From my point of view, the SplintMaster is the first real, true splint material. All the others are steps before. It does not, you have no taste. If you taste it, it does not smell. And also, it is much more faster to print. It is much more easier to clean. And finishing is also absolutely easy. Thank you very much. Also, a big thank you to Matthias that you was here today. It was really good. We learned a lot, and I'm sure it was not the last time here at the DETAX Academy with you together.
Thank you, Markus, for the invitation, and I'm happy if I can come back. Yes.
You're welcome anytime, of course.
Thank you.
Thank you, gentlemen and ladies and 3D printing nerds. And we will see you in about 2 months with the next webinar. Hope we'll see you again. Talk to you soon. Super gut. Vielen Dank. Das hat wirklich Spaß gemacht. Das war gut. In kurz gezeigt, wie es geht. Perfekt.